¿Cómo le hago? ¿Cómo le hago? Pues según es eso. Pues sí. Bueno, bueno, bueno. Hi, this is my presentation. Um, my name is Rosa Zuniga, and this presentation is about what I learned in math introduction to statistics. Why I learned math introduction to statistics by the prof. Ray Lapus. Empirical rule, probability, distribution, confidence interval, hypothesis, testing, and more. What I learned here and in what I studied while through the course. In Prof. Ray Lapos, Cañada College, in statistics. Statistics. What is statistics? The science of collecting, organizing, analyzing, interpreting data in order to make decisions. Describe statistics, organizing, and summarizing data. Concept population, collection of person, teams, urge under study. Sample, a select subset of all teams to study. Parameter, a number that is prepared population. Statistics, a number that is prepared of sample. Those concepts are really important to working with this class because in this class is about how working the population, how they doing the studies with examples and using parameters and statistics. Those topics is in this class: sampling and data, probability or normal curves, guaranteed time problems, normal distribution commands, sampling distribution, error-bound formula, EBM, T critical value, confidence interval, type 1 and type 2 errors, hypothesis testing, conclusion, chi-square test calculation, weight, weakest linear correlation, slope and equation health, scatter plot correlation types, plot trend line prediction, identify scatter plot outlier. Sampling data. In data, a sampling is subset of individuals or observations selected from a larger population, typically using a random or systematic method to represent the population is allow researchers to make the inference about the entire group. When studying, every member would be empirical. Example, write down the average time in hours to the nearest half hours. Units per night, where record data and then create a sample graph, call it a dot plot on the data. We can see here an image where the frequency average time in hours spent sleeping per night. 5, 6, 7, 8, 9. We can see the difference the frecuencia de sleep deeper and through the night. Other examples is real sample data. Pareto chart on light arrivals by reported causes. Here we can see the different numbers, the percents and the number where I show that traffic, childcare, public transportation, weather, oversleep, emergency. Descriptive statistics is 10 left plus another graph. That is 10 all digits except the last one in the left. The last digit if shows the shape of the data while keeping all the original values. Histogram, another graph. A histogram is a bar graph that shows how obtained data values fall into different intervals called bins. It helps visualize the distribution of numerical data, such as whether it's a symmetric, skew, or has order. Measure or location or are statistics that describe where the data is positioned on a number line. There, they tell you typical or central place of the distribution. Examples include mean, median, mode, percentile, and quartiles. Boss plots. A boss plot is a graph that displays the five numbers summary and data set minimum Q1 first quartile, median Q3 third quartile, maximum. Measure of center describe the middle of typical value of data set. The main ones are mean, average, median, middle value, mode, most frequent value. Is noise describe the shape of the distribution, specifically whether the data is stretched more the left or the right. Right square positive weak, tail of the right, left keyword negative keyword, tail of the left. So here we can see a lot of new vocabulary where what I'm learning through this class because before we never working with those vocabulary. Even this class is part of my responsibility to complete with my social degree. So, but even that is for me, this class is very important because here I had an opportunity to learn about the methods to do some equation to have one outcome in more. Other is probability calculation, probability formula. P P equal favorable outcomes total outcomes equal frag takes favorable outcome. And here we gonna see the graph where I show the frequency, also the number of the times teenager is reminded. So we can see how is grown out and down the line and also here I had the opportunity to learn to do this kind of equation or graph and when we can have one outcome. Standing the normal curve. This graph is different than before and where we can see the standard normal distribution and probability in warranty time manufacturers use probability normal distribution to predict the failure time, set warranty periods, reduce the financial risk. And here we can see this graph where we can see the frequency also and SAT score. So other is discrete random variable when we can see the different number in the different letters. Also, this random variable consider the function and here we can see the line and see the number how we can put the graph. The normal distribution. here we can see how the graph show the different numbers. In the central limit theoretical, here we can see we can learn and where is the position in is neutral or left of right. Hypothesis testing without sample. Here also is other new things where what I learned in this class is other new vocabulary. Where the hypothesis is equal, where the hypothesis is greater, where the hypothesis less than, where the p-value, when we can see the left tiled or right tiled, or we can see the test of the single population mean. Example hypothesis processes. This part for me is very interesting because to see one example to do one equation in this is really big because we had to do many things for one equation, but it's interesting because here I learning many things, and where I use it step by step to do this kind of question. For example, the make a statement, identify the claim, set up two contradictory hypotheses, test the hypothesis, collect sample, determine the correct distribution, perform the test, analyze the data by performing calculations. Make a conclusion, decide to reject or decline to reject another hypothesis, write meaningful conclusion that is framed around the claim. This example, this example say that a company claims that average lifetime of their phone batteries is this is the mean equal 500 hours. Example of 40 batteries. Sample means equal 485 hours. Sample standard deviation 60 hours. Test at 0.05 significance level. Here we want to test the true mean is less than 500 hours. So this is step by step. So in the first step, we can see the hypothesis mean in when HO mole equal 500 HA mole 500 is less than 500 hypothesis average mole 500 age average more less than 500. So average 0.05. And when I say that test statistics, T is equal 9.4868. Let's negative 15 equal negative 1.58 where the p-value, the freedom 41 negative 1 is equal 39. They created equal negative 1.685. Where the decision is negative 1.58 is no less than negative 1.685. So this say that fail to reject HO. Conclusion, there is no evidence on the 0.505 level to conclude that true mean battery lifetime is less than 500 hours. So, as appears a little complicated, but it's a lot of information for one claim, for one equation, for one outcome, but on many accounts because try many steps. Hypothesis testing with the two samples in here in decision in the conclusion. The that chi-square distribution and the test statistics for any test is always greater than or equal 0. When DD freedom is greater 90, the chi-square curve approximates the normal distribution for x 1000, the mean more equal the freedom equal 1000 in the standard deviation equal 2 in 1000. Therefore, equal 44.7, therefore x in 1044.7 approximately the mean more is located just the right of the peer. So linear regression and correlation. For me, this also interesting because here I learned to drawing the lines and to put the points in where I gonna put. For example, in the first image, put the negative in the positive, the negative y in the positive x. So um, here I learning that. And also in the second image, I learned how to put a point. For example, two in the two up. In the second eight to 5. In the third 3, 7. In the fourth 5, 6. In the six, 6, 4. Distribution in one way, ANOVA. So here is really interesting. And that's it. So maybe I learning more about this class, but it's a lot of information. But for me, it's really interesting everything about statistics.